Welcome to the AWS Certified Cloud Practitioner Prepcast, where we guide you through everything you need to know for your certification exam. Whether you're just starting or looking to refine your knowledge, this course will set you up for success. Brought to you by baremetalcyber.com. Let's get started. Organizations that adopt cloud often face the challenge of integrating existing on-premises storage with AWS services. AWS Storage Gateway addresses this by serving as a hybrid storage bridge, allowing companies to connect their local infrastructure to cloud-backed resources seamlessly. Delivered as either a virtual machine, hardware appliance, or even as a hardware device sold by AWS partners, Storage Gateway enables businesses to continue using familiar storage protocols while gaining the durability, scalability, and cost advantages of S3 and related services. It is not about replacing local storage entirely, but about extending it intelligently into AWS. At its core, Storage Gateway is designed for three primary use cases: backup, archive, and cloud tiering. Many organizations have decades of data stored in file servers, block storage arrays, or tape libraries. By deploying Storage Gateway, they can modernize these storage patterns without rewriting applications or retraining staff. For instance, data that once filled physical tapes can now be managed as virtual tapes in the cloud. And file shares that once required expansive SANs can now back onto S3. This makes Storage Gateway a transitional technology for enterprises moving toward cloud-first strategies while still operating hybrid environments. The most widely used mode is the File Gateway, which presents standard NFS or SMB file shares to on-premises clients while storing objects in S3 as the backend. To users and applications, File Gateway behaves like a normal file share, but behind the scenes, files are stored as objects in S3, complete with metadata preservation. This design allows enterprises to keep familiar workflows while benefiting from cloud durability and lifecycle management. For example, backup software writing to SMB shares can seamlessly transition into storing backups in S3 without knowing the underlying change. File Gateway further supports Active Directory integration when used with SMB, enabling authentication and user-based permissions consistent with enterprise standards. It also includes SMB features, such as access-based enumeration, which hides folders users don't have rights to, creating a familiar and secure experience. Shares can be mapped directly to S3 buckets or even prefixes within buckets, allowing administrators to segment storage by team, department, or workload. This combination of protocol compatibility and S3 integration makes File Gateway a strong choice for enterprises that need hybrid access to object storage. For block workloads, AWS provides the Volume Gateway, which exposes ISCSI block volumes to on-premises servers. Two modes are available: cached volumes, which store primary data in S3 while keeping frequently accessed data locally, and stored volumes, which maintain a complete local copy with asynchronous replication to AWS. Cached mode minimizes on-premises storage requirements, while stored mode emphasizes local performance and offline resilience. Both modes allow snapshots to be taken and stored as EBS snapshots, providing point-in-time recovery and easy integration with AWS backup workflows. Snapshots created through Volume Gateway are incremental, capturing only changes since the last snapshot. These can be copied across regions or used to create new EBS volumes, giving organizations flexibility in both backup and disaster recovery planning. For example, a business could replicate critical database snapshots into another region for resilience, or restore volumes quickly after a local system failure. This makes Volume Gateway not just a hybrid connector, but also a bridge into AWS's backup and recovery ecosystem. The Tape Gateway mode virtualizes traditional tape libraries, allowing organizations to replace aging hardware with virtual tapes that write directly into S3 and S3 Glacier tiers. Applications see the gateway as a standard tape library, requiring no workflow changes, while data is transparently archived in cloud storage. tapes can be transitioned into Glacier Instant Retrieval, Flexible Retrieval, or Deep Archive, providing cost-effective long-term retention. This is especially useful for regulated industries that must preserve data for years or decades, while eliminating the overhead of managing physical media. Key to all gateway modes is the local cache, which stores frequently accessed data and buffers uploads to the cloud. Proper cache sizing and placement are critical for performance. If the cache is too small, repeated data access will thrash performance. Placing the cache on fast local SSDs improves responsiveness for workloads like file shares or databases accessing hot datasets. This blend of local caching with cloud storage allows gateways to offer both speed and scalability, provided administrators plan capacity wisely. Deployment of storage gateway can occur as a hardware appliance, a virtual machine running on existing virtualization platforms, or as a standalone hardware device purchased from AWS. The choice depends on infrastructure maturity and workload scale. Smaller offices might prefer a VM-based gateway running on VMware or Hyper-V, while enterprises needing dedicated performance may invest in hardware appliances. This flexibility makes storage gateway accessible to organizations of all sizes, with deployment options that align to existing operational practices. Security is built into the service, with encryption in transit using TLS and encryption at rest through AWS KMS. Administrators can enforce encryption policies and manage keys centrally, ensuring compliance with corporate or regulatory requirements. Each gateway assumes an IAM role that defines which S3 buckets or services it can access, following the principle of least privilege. By tightly scoping permissions, organizations prevent gateways from interacting with resources outside their intended boundary. Security, therefore, is enforced both at the network layer and the identity layer. Cost for storage gateway includes several components: the storage consumed in S3 or Glacier, request charges for reads and writes, retrieval fees for archived data, and any local appliance costs if hardware is used. While file and volume gateways mostly incur S3-related charges, Tape Gateway introduces retrieval fees tied to Glacier tiers. Additionally, managed hardware appliances add a subscription fee. Understanding these costs is important, as the apparent simplicity of hybrid storage can mask complex billing if data retrieval patterns are not accounted for. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. Performance tuning with Storage Gateway starts with correctly sizing the local cache. The cache stores frequently accessed data and buffers writes before they are uploaded to S3. If the cache is undersized, workloads will suffer from repeated fetches across the WAN, increasing latency and network load. Administrators should also optimize parallelism by enabling multiple client threads or streams when accessing the gateway, ensuring data pipelines fully utilize available bandwidth. Network path design also matters. Using Direct Connect or private VPC endpoints reduces latency and jitter compared to traversing the public internet. For environments using File Gateway in SMB mode, managing permissions carefully is essential. Best practices include aligning SMB shares with Active Directory groups, enabling access-based enumeration so users see only the folders they have rights to, and auditing access through Windows Event Logs or CloudTrail. These measures ensure that sensitive data is protected without introducing operational friction. Similarly, for NFS shares, administrators must pay attention to POSIX ownership and permission semantics, mapping user IDs and group IDs consistently between on-premises clients and the gateway. Inconsistent mappings can cause access errors or inadvertent exposure. Lifecycle management integrates Storage Gateway with the economics of S3. While data lands initially in buckets, S3 lifecycle policies can automatically transition files into standard IA, one-zone IA, or Glacier tiers. For example, backups uploaded through File Gateway may stay in standard for 30 days and then shift to Glacier Deep Archive for long-term retention. This automation reduces storage costs while still preserving accessibility when needed. Gateway users don't have to change workflows. Administrators manage lifecycle rules at the bucket level, and the system quietly optimizes cost in the background. Visibility into gateway activity comes from audit and monitoring tools. CloudTrail data events can log every access to S3 objects written through the gateway, providing full traceability of reads, writes, and deletes. File share activity can also be logged, ensuring accountability for user actions. Combined with CloudWatch metrics, these logs create a comprehensive picture of performance, usage, and compliance. For regulated environments, audit trails ensure that hybrid file access remains transparent and defensible under governance frameworks. Disaster recovery planning is another key capability. With File Gateway, data stored in S3 can be restored directly into new gateways, recreating shares quickly in another site or region. Tape Gateway extends this by offering virtual tapes that can be restored into new appliances or directly retrieved from Glacier tiers. Volume Gateway snapshots, stored as EBS snapshots, provide flexible recovery paths, creating new volumes, restoring into different regions, or building AMIs for system recovery. These features ensure hybrid storage aligns with modern DR strategies, where recovery speed and flexibility are just as important as data durability. Tape archival workflows highlight the importance of retrieval choices. Virtual tapes can be moved into Glacier Instant Retrieval for millisecond access, flexible retrieval for hour-scale access at lower cost, or deep archive for the cheapest, longest-term storage with retrieval times measured in hours. Organizations must balance how quickly they may need data with how much they are willing to spend on retention. For compliance-driven archives that are rarely touched, Deep Archive provides the lowest cost. For business continuity plans requiring faster restores, instant or flexible retrieval may be worth the premium. Network planning remains critical in hybrid deployments. Storage Gateway depends on reliable connectivity to AWS, and performance is highly sensitive to bandwidth and latency. Administrators should size network links to match expected data flows, use QoS to prioritize gateway traffic, and consider redundant paths for resilience. For latency-sensitive workloads, Direct Connect or private endpoints reduce dependency on the public internet, improving consistency. Misjudging bandwidth needs is a common pitfall that leads to user frustration and failed SLAs. Security posture for Storage Gateway follows AWS best practices. Keep traffic private whenever possible and scope IAM permissions narrowly. Configuring VPC endpoints ensures that Gateway to S3 traffic does not traverse the public internet. Gateways should assume IAM roles with least privilege policies, allowing access only to the required buckets or prefixes. Encrypting all connections with TLS and using KMS for at-rest encryption ensures confidentiality across the full lifecycle. By treating the gateway as both a storage and network component, administrators enforce strong security on both planes. It is also important to distinguish between DataSync and Storage Gateway. Both can connect on-premises storage to AWS, but their purposes differ. DataSync is designed for bulk migrations and one-time or recurring transfers, often moving petabytes into the cloud efficiently with parallelism and compression. Storage Gateway, by contrast, is for ongoing hybrid access, allowing on-premises clients to read and write directly to cloud-backed storage. Confusing the two can lead to misaligned designs. DataSync is for migration, Gateway is for integration. Enterprises often deploy Storage Gateway in multi-site environments, consolidating data from branch offices into central S3 buckets. Each site can run a file gateway, allowing local users fast access while the backends unify in S3. This consolidation simplifies backup management, centralizes compliance enforcement, and reduces costs compared to maintaining isolated file servers everywhere. Gateways act as the connective tissue, ensuring local performance but central cloud governance. Administrators should watch out for common pitfalls. An undersized cache will degrade performance as users repeatedly fetch cold data from S3. Overly permissive IAM roles risk exposing sensitive data by giving gateways unnecessary access to multiple buckets. Clock drift on on-premises hypervisors hosting the gateway VM can break authentication or cause replication errors, underscoring the need for time synchronization. Awareness of these issues helps prevent hybrid deployments from falling short of expectations. On exams and in practice, mapping the right use case to the right gateway mode is essential. File gateway applies when applications need NFS or SMB file shares backed by S3. Volume gateway fits when block storage over ISCSI is required with snapshots managed in EBS. Tape gateway is the answer for virtualizing tape libraries and pushing archives into Glacier tiers. These associations simplify scenario-based questions and guide practical design. If the exam stem mentions SMB, ISCSI, or tape replacement, the corresponding gateway should come to mind immediately. By mastering storage gateways' performance tuning, access controls, lifecycle integration, and disaster recovery workflows, organizations can confidently extend their on-premises environments into AWS. The key is recognizing that hybrid storage is not just about bridging technology. It is about blending operational familiarity with the scalability, durability, and economics of the cloud. Storage Gateway delivers that blend by preserving existing interfaces while modernizing the backend with S3, EBS, and Glacier. This balance makes it a cornerstone of hybrid cloud strategies. That concludes today's episode of the AWS Certified Cloud Practitioner Prepcast. Be sure to tune in for the next episode and visit us online at baremetalcyber.com or cyberauthor.me for more resources, including news, mailing lists, YouTube videos, podcasts, and much more.